Okay, so I'm going to explain how to do integration by parts, and I'm also going to do a couple of basic examples so that maybe you can get the hang of what we're talking about here. So I'm going to go ahead and write the formula first, and then I'm going to explain what this formula means, because it's a little confusing. Okay, so we're going to start out with integral of u times dv is equal to u times v minus the integral of v times du. Okay, so this part right here is usually where you're going to start. And I would say that this is basically the product rule for integration. It's kind of a misuse of the word because the product rule is a rule for derivatives. However, this is going to allow us to take the integral of the product of two different functions that we know something about. So if you notice in the formula, this u here, if we look down here at the very end, there's a du. So that means whatever we choose to be u, we need to be able to find the derivative of u. And again, if you notice that this dv right here on the left has a corresponding v, actually there's two of them. So basically we need to choose something called dv so that we can find the antiderivative of that function. So just to recap, we need, this is a method for integrating the product of two functions. One of them you have to be able to find the derivative, and one of them you have to be able to find the antiderivative, or sometimes known as the integral. So I'm going to give a couple of basic examples here so you kind of see how this works. And first one is going to be, actually I'm just going to rewrite the formula here. Integral of u times dv is equal to u times v minus integral of v times du. Okay, so we're basically going to, so we're going to try and integrate this function here. Integral of x e to the x times dx. So if you notice, there's no easy way to integrate this using the substitution rule or any of the power rules. Like any of the integral rules that came before this would be unable to tackle a problem like this. So now we're learning a new method. Okay, so we're going to assign u, we're going to assign dv, and this is going to work similar to like a u substitution. So right now u and dv are both going to be containers that are going to contain functions. So u, for the integral that I have here on the right, this one, if you remember, u needs to be chosen so that we can easily find du, or the derivative of u. So I'm going to make u equal to x. That would make the derivative of u dx. And I'm going to choose dv to be, so x has kind of been accounted for, and I'm going to make dv the remaining part of this integral here. So that's going to be e to the x times dx. And if we integrate dv to, like we're working backwards, right? The function v, who has a derivative of dv, is going to just be e to the x. So this is kind of a special case because e to the x is its own derivative, and I'll do another example in a moment. Okay, so if we apply this formula, the integral of u times dv, which would actually be x times e to the x dx, which is what we have over here in the box on the right, is going to be equal to u times v minus the integral of v times du. Okay, so it actually looks a little bit more complicated. There's more terms, but in fact the integral over here on the right hand side is quite a bit simpler than the original one that we had. Okay, so I'm just going to simplify this a little bit. We have x times e to the x minus the integral of e to the x dx. As you might already know, the integral of e to the x dx is e to the x. So what we have here is x times e to the x minus e to the x plus some constant. And then, no, I think we're done. You could factor out an e to the x from these first two terms here. Call this e to the x times x minus 1 plus a constant. I would say probably either one of these are correct. It just depends on maybe what your professor thinks or if you like it stylized a certain way. Okay, so I'm now going to do another example very quickly. So for this one, we're going to do the integral of x squared times ln of x times dx. And again, we're going to apply the formula for integration by parts, which is u integral of u times dv equals u times v minus the integral of v times du. Okay, so I'm going to choose u such that we can find its derivative, and I'm going to choose dv such that we can find its antiderivative. So in this case, I'm going to choose u to be the ln of x, and the reason for that is it would be fairly easy to find the derivative of u, because that's going to be 1 over x times the dx. And I'm going to choose dv to be the x squared times dx, and that would make v, the antiderivative, 1/3 of x cubed. Okay. In this particular example, if we had done it backwards, we would be unable to get an answer. If you made u equal to x squared, you could find the derivative of that. And if you made dv equal to ln of x, you would be unable to find the antiderivative. So sometimes you can tell immediately whether or not you've done it correctly. Sometimes you have to go through it and then later realize that you've done it backwards. Okay, so if we apply the formula, this integral is going to become u times v minus the integral of v times du. And now before I solve this integral on the right hand side, I'm going to simplify it a little bit, because this x cubed and this 1 over x actually just can cancel out and leave us with an x squared. Okay, so what we have so far is ln of x times 1/3 of x cubed minus, we can put the 1/3 on the outside because it's a constant multiple, and then this little x cubed times 1 over x is actually just x squared times the dx. Okay, so then we'll continue. Actually, this part right here, I'm just going to write it as 1/3. No, I'm going to write it as 1/3 x cubed times the ln of x minus 1/3. And now this integral here becomes 1/3 x cubed plus some constant, right? Okay, so if we simplify a little further, we've got 1/3 x cubed times ln of x minus 1/3 plus some constant. And I would probably just leave the answer like this, because this looks pretty nice. If you notice, I factored out the 1/3 of x cubed in both terms, put it on the outside, and what you'd be left with is ln of x minus 1/3. So that's going to be my last example. If you have any questions, let me know.